In this video, we are going to show Pythagoras' theorem. Pythagoras' theorem is for any right-angled triangle ABC, the length of the corresponding sides A, B, and C related by the Pythagorean equation a squared plus b squared is equal to c squared, where c represents the length of the hypotenuse and a and b are the lengths of triangle's two sides. If we put in a rough sketch, this is a right-angled triangle with this symbol, right-angled triangle symbol. Now what we call the hypotenuse is this one. This is the hypotenuse, the diagonal side of a triangle, the longest side of a triangle. And the triangle two sides are these sides and that sides. Now let's get into action. We will use a Pythagoras theorem to solve some problems in geometry. Consider this right-angled triangle with two given sides, 7 centimeters and 24 centimeters. Now let's remember the Pythagoras theorem. Pythagoras' theorem is a squared plus b squared is equal to c squared. You just need to remember that c here not necessarily means c in the problem. C here is the hypotenuse. And a here not necessarily means that a in the problem. Now to solve this problem, let me write the Pythagoras theorem up here. Now since c is the hypotenuse or the longest side in this triangle, then c would be equal to a squared. And the other two sides of this triangle would be 7 squared plus 24 squared. Now I'm going to simplify the left hand side of this equation. 7 squared is 49, 24 squared is 576. That is equal to a squared. Sum up the left hand side, that is 625, that is a squared. Taking square root on both sides, square root of 625 is equal to a. And so, if you put that number in your calculator and find the square root of it, then what you get is 25. So that is the value of a. Now since we work in centimeters, I would say that a is 25 centimeters. That's how you solve a problem using Pythagoras' theorem. For our next example, we are going to consider this problem. In this problem, we are going to find f. In order to find f, we are going to use Pythagoras' theorem, which is a squared plus b squared is equal to c squared. C squared here is the hypotenuse or the longest side of this triangle. In this case, f squared will act as c squared. And we can put the other two sides as a and b. And I'm going to put these two sides as a and b. So a would be 50 squared and b would be 80 squared. Simplifying the left hand side, it would be 2500, and for 80 squared, it would be 6400 by using calculator. I'm going to simplify the left hand side, sum these two numbers, I would get 8900, that is equal to f squared. And so, square root both sides, I would get square root of 8900 is equal to f. If you put these numbers in your calculator, you will get decimal numbers. So leave the answer in the third form because it is exact value. So f, leave it as root of 8900, put it centimeter. This is how we solve this problem using Pythagoras' theorem. For our next example, we are going to consider this problem. Here we are going to find g in meters by considering this right-angled triangle because we have that symbol, and also this small symbol here means that it is an isosceles triangle. What special feature of isosceles triangle related to length? Yes, isosceles triangles have two sides with same length. Signed by that small thing, you can say that this is also for meters. Now we are going to apply Pythagoras' theorem. Pythagoras' theorem is a squared plus b squared is equal to c squared. C squared here is the hypotenuse of this triangle. hypotenuse of this triangle, or the longest side of this triangle. So this is the longest side of this triangle. So in this case, c square is g square. And how about a and b? A and b would be the other two sides. In this case, it's 4 meter and another 4 meter. Now if we calculate left hand side of this equation, it would be 16 plus 16, that is g square. Sum it up, you get 32 is equal to g square. And if we take square root on both sides, there will be 32 is equal to g. Now if we take square root of this, so if you put that number in your calculator, you will get the numbers with a decimal value. But it would be better to keep it in the third form if you want them in exact value. This is how solve a problem with Pythagoras' theorem involving right angle triangle and isosceles triangle. So it's square root of 32 meter here.